So in the glycolytic pathway, our starting point is with what? Glucose, right? So if you are starting the pathway, first of all, you draw the structure of glucose, which we can all draw now. So I'll draw the structure of glucose. Please, listen up. I'll give you time to draw. Just listen up. After glucose, the next thing is what? In the pathway, after glucose, the next stop is what? Glucose 6 phosphate, right? As you're calling it, glucose 6 phosphate. Meaning you are putting phosphate group on position 6 of what? Of glucose, right? So you are going to draw this glucose molecule again, but now you are putting the phosphate group on carbon what? 6. And if you are numbering it, this is carbon what? 1, 2, 3, 4, 5, 6, right? So on this carbon 6, you are going to put a phosphate group to get your glucose 6 phosphate, is it not? So we'll be having this. If I have this is what? My glucose, right? Now glucose 6 phosphate means attach phosphate group to position 6. So I'll just remove one hydrogen here and put my phosphate group. You are free to put your phosphate right like this. If you are writing just P, put it in box brackets, in brackets. But the full phosphate is this. So you can decide to use this or you use this. Anyone, you're okay. Do you get that? So now what we have is glucose 6 phosphate, right? Now the next step after glucose 6 phosphate is what? Fructose 6 phosphate, right? Alright, good. Now to draw the structure of fructose, because the name is fructose 6 phosphate. To draw the structure of fructose is how many carbon? 6 carbon too, right? Now I know in your previous research course you were taught pyran and furan, right? Glucose, is it pyranose or furanose? Or you forgotten? Okay, now you agree with me that the structure of glucose of fructose looks like this, is it not? Then here you have CH2OH, CH2OH. Is it not? The OH here is up, here is down. Count, how many oxygen do we have? 1, 2, 3, 4, 5. It's supposed to be how many? Supposed to be how many? The oxygen is supposed to be 6, right? So where do I put my last oxygen? Yeah, OH, H. If I'm numbering this is my carbon 1, 2, 3, 4, 5, 6. And we said fructose what? 6 phosphate. Meaning on carbon 6, I'm putting what? Phosphate group, right? So now what I have is fructose 6 phosphate. Please feel free to complete all these places your hydrogen. All these points with your hydrogen. And please, if you are not following at any point, let me know. We've drawn glucose, we added phosphate to get glucose 6 phosphate. From glucose 6 phosphate, it was isomerized to fructose 6 phosphate. Now, the next thing is what? Fructose what? 1,6 dissociate, right? Have you done this? You spoiled my video. Jesus Christ. This fructose 6 phosphate, right? Right to this point and draw fructose 1,6 dissociate for me. So draw from here to here and draw the next one, fructose 1,6 dissociate. You can all draw it. You can all draw it. So draw from here to this point and draw fructose 1,6 dissociate for me. It's not difficult because you all got it. Now we are drawing the structure of fructose 1,6 dissociate. 1,6 dissociate means 2 phosphate, right? 1,6 means in phosphate 1 is on position 1, right? and the other one is on carbon 6, is it not? So you just draw this structure again, this structure of fructose 6-phosphate. So this fructose 1,6-bisphosphate, because these are carbon 1 and these are carbon 2, and we place phosphate group on carbon 1 and carbon 2. If you took this one to this side, there's no problem. You don't have any issues. Like if this was on this other side, there's no issue. So this fructose 1,6-bisphosphate. Fructose 1,6-bisphosphate. The next one in the pathway is what? Fructose 1,6-bisphosphate will be cleaved to two stuff, right? What and what? Dihydroxyacetone phosphate and what? Glyceride 3-phosphate. All right, good. Now to draw those two intermediates are not difficult. So here I will draw dihydroxyacetone phosphate here, and here I will draw glyceride 3-phosphate. Now, first question: dihydroxyacetone phosphate, what functional group is found there? Is it ketone or aldehyde? Ketone, right? Glyceride 3-phosphate, what functional group is found there? Aldehyde, right? And we know there are three carbon intermediates, right? Because this 6 carbon stuff we break down into 3 carbon, is it not? So this one is 3 carbon, dihydroxyacetone phosphate, 3 carbon, glyceride 3-phosphate, 3 carbon, is it not? Now, if this is 3 carbon, we already know this is 3 carbon. If we have 3 carbon molecule here, and we want to have a ketone, where will I put my carbonyl carbon? Is it carbon 1, 2, or 3? Carbon 2, right? Good. Now they said dihydroxyacetone phosphate. Dihydroxy. Dihydroxy means 2 hydroxy group, right? So I will put one hydroxy group here. OH. This is one hydroxy group. I'll put another hydroxy group here. So what I now have is what? Dihydroxyacetone, right? Is it not? Dihydroxyacetone. But they say dihydroxyacetone phosphate, meaning one of these should be having a what? A phosphate group. This is dihydroxyacetone phosphate. Forget about the long name, just look into the meaning of the name. This is dihydroxyacetone phosphate. Do we get? After now, you will draw this pathway from the start to the end for me with structures. Now, glyceride 3-phosphate. Now, glyceride 3-phosphate. We already know it's 3 carbon. 1, 2, 3, right? Glyceraldehyde. We know aldehyde functional group is there, right? An aldehyde functional group. This aldehyde functional group. Is it not? Then glyceraldehyde 3-phosphate. 3-phosphate meaning the phosphate group is on position 3, right? So what will happen to this one now? This is a glyceride 3-phosphate. This is glyceride 3-phosphate. We already know that from glyceride 3-phosphate, dihydroxyacetone phosphate cannot continue in the pathway, right? So it's converted to another molecule of this, right? And please, let's use the right way of representing this. Now, glyceride 3-phosphate to be converted to a molecule of what? 1,3 what? 1,3-bisosoglycerate. To draw 1,3-bisosoglycerate is very easy now. It's just with this structure, but we are putting phosphate group on carbon 1 to make it 1,3-bisosoglycerate. Do you get? Now, if I'm to draw 1,3-bisosoglycerate, this is what I will do. 1, 2, 3. At this point, on position 3, my phosphate group is already there, right? Position 2 remains the same. 1,3-bisosoglycerate. Yeah, what do I add? Phosphate group, right? But I cannot just attach phosphate group like this. So I have oxygen, right? So this is my 1,3-bisosoglycerate. 1,3-bisosoglycerate. This 1,3-bisphosphoglycerate. The next one is what? 3-phosphoglycerate, right? What do you think? Phosphate group will be leaving where? Position 1. So if phosphate group is going out from position 1, we'll be having only O will be left here, right? The phosphate group is going out. This is my what? 3-phosphoglycerate. From 3-phosphoglycerate, the next thing is what? 2-phosphoglycerate. So what do you think? The phosphate group is moving from here to where? So the OH will come back here, right? You have your 2-phosphoglycerate. So this is my 2-phosphoglycerate, right? After now, we are going to draw it from the starting again together and move to the next pathway. So 2-phosphoglycerate. From 2-phosphoglycerate to what? Check what is happening in phosphoenol pyruvate. Just look up, check what is happening in phosphoenol pyruvate. In phosphoenol pyruvate, what is actually happening is removal of water. That is why the name of that enzyme catalyzing that reaction is enolase. Catalyze the removal of water. And you agree with me that water is H2O, right? That is HOH. Now OH from here, we take one hydrogen from here and water will go out, right? So this OH will take one hydrogen from here. So let's do that. If you have something like this, if I'm removing one hydrogen from here, it's remaining what? 3, right? I still have my phosphate here. And I've removed OH from here, right? So, but if you check, this carbon is having how many bonds? 2, 3, right? This carbon is having how many? This other carbon is having how many? Sorry, this was, please, check up. We're doing the wrong thing since. This one carbon, not 2. If you count, it's more than. So what's supposed to be here is 1, 1, 1. If you remove one hydrogen from here, now the hydrogen that was there, if you remove it from here and remove OH from here, if you check, this carbon is having 1, 2, 3 bonds, right? This other carbon is having 2, 3. So what do we do to complete it? Put a double bond there. So with a double bond here, this carbon is now having 1, 2, 3, 4 bonds. This other carbon is having 1, 2, 3, 4 bonds. This is your phosphoenol pyruvate. This is also phosphoenol pyruvate. Please don't give up. Oh. You take it again and you'll get. If you give up now, then you've given up forever. Because you still need this until you graduate. This is the BCH you came for, or they gave you. Alright, so phosphoenol pyruvate. The last thing is what? Pyruvate. And pyruvate, the structure of pyruvate. The phosphate group is going out. So if the phosphate group goes out, we have this. This is pyruvate. So basically, this is the glycolytic pathway with structures.